Hey guys, today we're going to be presenting to you guys 14 advanced object-oriented design patterns featuring the games Tower Defense, PartyParty, and AstroBlaster. Featuring today on the team is me, Tamer Ayub, Kasai Funun, Simon Rested, and Ryan Wilkin. So on the agenda today, we'll be covering Tower Defense, AstroBlaster, PartyParty, and a console application featuring all 14 patterns.
So hello everyone, my name is Kusai and today I'll be presenting 4 of 5 design patterns that we implemented in our tower defense project. The patterns are command, strategy, singleton, and visitor. So let me start first of all with the command pattern. So why are we using the command pattern? In our tower defense, we have this camera that can be moved using the WASD keys, and we can zoom in and zoom out. So if we check the editor very quick, and if you see, like I'm clicking WASD, and you can see the mouse is in the middle of screen, so I'm not using the mouse. And when I scroll, you can see that I'm moving like zoom in, like I'm moving in and out from the screen. And let's check the code very quick. So if we go to the command pattern, we have a command controller which has like definitions for these commands. You can see move forward, move backward, left, right, and zoom. The zoom is basically using the mouse input, and this will be using the left, back, and right, and forward. So if we check the input handler, we are defining here the commands. As you can see, button A, D, W, S, and scroll wheel. And you can see here, we executing command button W, S, D, and A, and here scroll wheel. And the invoker here will make sure that we're executing the command, and these are the commands. Now, let me talk about the second design pattern, which is the strategy pattern. So in our tower defense game, we have different types of turrets. So these turrets will also have different kind of like cost and upgrade cost. So instead of like using multiple classes to define each task, each turret by itself, you can see here in the build manager, we have this turret blueprint, and this turret blueprint actually is using the strategy pattern. So let's check that very quick. So this turret blueprint has an integer for identifying the cost and upgrade cost with the prefab and the upgrade prefab with the sale amount. So if we check the laser beam class, the initial cost here is 350, and the upgrade cost is this 200. And as you can see, we have a laser beam constructor which will calculate the cost and the upgrade cost with the sale amount. So in this case, these 3 classes can inherit from the turret blueprint and can be used as a single object instead of creating multiple objects, and it can be run like in real time without having to identify multiple classes or multiple variables for each one of these classes. And if you check right here, let's click on play again, you can see that it is fully functional, and here is the total cost for the standard turrets, which is 100, and this is the missile launcher and the laser turrets. And this way, we didn't have to like create, as I said before, multiple like definitions for all of these turrets. Now, finally, not finally, I still have two more patterns. The singleton pattern is basically used to make sure that we have only one instance of an object in our game. So we have multiple levels. So like we have two levels, as you can see here, assets. So we have level 1, level 2. So the singleton pattern will make sure that we have like an instance of the game manager, build manager, and so as the iTerrent controller. These controllers are inheriting from the singleton class, as you can see right over here, and we click hit. There will be an object called don't destroy game object, as you can see here, game master, and you can see all these scripts are attached to the game manager. So in this case, we don't have to create multiple instances of this manager in different levels. So let's check the singleton class very quick. As you can see here, we will make sure that there is only one instance of an object. Otherwise, we will destroy the object in case of any duplicates. And I introduced the singleton pattern before the visitor pattern because the visitor pattern itself is using the singleton pattern in its turret controller. So the turret controller is basically the one responsible for executing the visitor pattern. We have an iVisitor, iTurret element with the turret class and power up and client visitor. So let's check the code structure very quick. So when we go to the visitor pattern, we have the client visitor, which will basically like takes an attack range power up, and it will also take a reset attack range power up. And these power ups are basically scriptable objects, can be created in Unity. So this basically will identify the kind of power ups and the settings for each of these power ups. So as you can see, if it is not reset, then we want to increase the attack range. Otherwise, we want to reset that to the turret default attack range. So this is the interface for the visitor class, which is basically taking a turret element, and let's check the turret class. So the turret class will accept an visitor, which in this case we will be like upgrading the attack range, and let's see that in action in Unity. So I wanted to create such like some kind of like a collectible object. Like after you destroy enemies, you like you will get like kind of prefab that you can collect and improve the turret attack range. But it was a lot of hard work. So as you can see, the enemy passed by the turrets and nothing happened. So when we click on power up attack range, you can see it starts shooting the enemies from like very far distance. Like if I even try to add more, you can see they're not attacking. So when I start clicking on power up, as you can see, all these turrets start attacking from like far distance. When I click on reset, all these turrets stop attacking, but when they enter the cast range, they start shooting again. And this is basically all the 4 design patterns that I wanted to introduce in our tower defense project. And now my colleagues and teammates will continue with the rest of the presentation.
So here's the observer pattern. And the main problem we had and why we applied the observer pattern was simply because we wanted to make sure that we listened to components without having too much of a dependency. A lot of our components were tightly coupled components, and we wanted to make sure that when we did this game, that there wasn't going to be a strain from component to component, and that we would be able to listen to what someone, aka a component, is telling us without having to be too attached to it. So this is why we applied the observer pattern. Because what the observer pattern does is it lets us have loose coupled components where we can subscribe, unsubscribe whenever we want and whenever we're done listening. We don't have to know exactly how a component works to understand and to listen to it either. We simply just have to subscribe and we get the data and the current state of whatever we want. And in this game, this is how the observer pattern works. So the plan is we have, and when you do the observer patterns and when you apply it inside your applications, you will have two interfaces. You'll have the observable and you will have the observer. And in this case, for our game, we have observable lives and observer lives because we want to listen to lives, because we want to know when we should end the game. And as you can see, for the game manager will be the observer because the observer is going to be listening to the observable. And player stats, this is where we contain how many lives we have. So we want to make sure that we're listening to that in our game manager. So that is why this is the observer. And as you can see, we have three methods in iObservable. We have notify, subscribe, and unsubscribe. As you can see in player stats, we went further and added definition to each of these methods. And these methods are very important because this is where we're going to be able to subscribe and unsubscribe different components we want to listen to player stats or whatever example that you have in your games. We're going to go ahead and talk about our Observer Lives UI. And right off the start, you can see that we subscribe this straight to the subject player stats. And on update, we're displaying how many lives we have using the function and display in player stats. And as you can see, all the methods from our initial interface that we talked about before, iObservable lives, we put them in here. And this is how we define what the functions do. And here, this keeps track of how many different observers we have. For example, each different radio station is going to be in this list listening. But for this example, it's Lives UI and Game Manager. We're going to go ahead and go into the Game Manager, and I'll talk about why the Game Manager needs to listen to the lives. So as you can see, the Game Manager deals with ending the game. So this is why we're going to have to listen to the lives. And as you can see, when player stats lives is below 0, we go ahead and end the game. Welcome to PartyParty, featuring the patterns Flyweight and the sandbox pattern. And why this game is unique is because we're featuring characters such as SpongeBob SquarePants, Homer Simpson, and Bugs Bunny, where they'll be having a dance-off party inside a disco apartment. The pattern that I applied here was the flyweight pattern. And what was the initial problem that I faced in the game, and why did I apply the flyweight pattern? So the problem I had is I had a lot of disco lights, as you can see in the right-hand corner in the picture. What I had to initially do was make a copy of each of those lights and add a material, which is inefficient because imagine if we have 1,000 lights, we would have to create 1,000 copies, which is very hard on the processor. And my answer to that problem was instead of just making a copy for each of the components, let's just share components. So what I did here and what the plan was, instead of applying a copy to each of the objects, we're instead going to make a prop block and share this prop block with all of the objects. So let's take a look at how the script is looking for the old way of doing this. So I know a lot of us use this way when changing colors in Unity, and this isn't a bad way of doing it actually. But when you want to make sure that you're changing properties of many different objects at one time, this part can become very ineffective really quick. So what this is doing is, like we looked at in the diagram, it's assigning a copy to each individual object, which is inefficient and ineffective. Okay. So now if we look at the new way of doing this with the flyweight pattern, it's almost the same exact script. You can kind of see renderer, rendered object, renderer, rendered object, and on awake, we're basically saying get component renderer. What this lets us access the render component of each of the objects, and then we're instantiating a property block on awake. So basically, before the game starts, do all of this. Okay. And then we have a function that gets a random color. And then on update, what we're saying is since the property block lets us be able to assign many different objects with one property block, this is what lets us apply the flyweight pattern, because the whole concept of the flyweight pattern is reusability. Okay. So we can see here that rendered object, which is all of the cubes in the game, we're going to get the prop block for all of those cubes. Okay. And then we're going to set the color of the prop block to a random color. So now say the prop block is purple in this update iteration. So now we're setting all of the objects to purple. Okay. And then every time on update, this is going to keep on running. And it's not going to become inefficient because, as you can see, all the objects are assigned just one property color altogether, instead of having to make a copy for each object. And I'll kind of show you visually what's happening in the game when you do it the old way versus when you do it the new way. So you can see that this cube, if you look at the lower right hand corner of the screen, this specific cube uses the old way of doing it, and you can see that the material instance is changing on update, which is creating a copy of the material, which is inefficient and ineffective. As you can see, this one does it the old way, and it's also creating a copy of the material on update, and this is also doing it the old way. But all the other cubes in the game do it the new way, and as you can see that nothing is changing, but the color is changing because all of the cubes going down this list is doing it the new way. So this is how we're able to make sure that we change colors of many different objects the most effective and efficient way possible. And here we have the sandbox pattern. And so the reason why I wanted to apply the sandbox pattern was because I wanted each character to have their own variation of jumping. It wouldn't make a lot of sense to make Bugs Bunny jump the same height as Homer, right? So the problem here was just not having any function variation. And that's very common. Usually people would go around making multiple functions for each of the characters. But I'm going to show you how we can only have one function with multiple different variations. And our answer is to have subclass variation. What we're going to do is, and for the plan, as you're going to be able to see in the next slide, is we're going to have a main class called jumping, which is an abstract class, with an abstract method called activate, with the main method where we're going to have variations for jump. And as you can see, we have 3 child classes: low jump, medium jump, and high jump. And this is how we're able to have different variations of jump. We're inheriting the jump method. We're also inheriting the activate method. And what we're doing inside the client is we're seeing whether if we hit E, R, or T, if we hit E, we're going to make Homer jump. And I assigned the low jump to Homer because I don't think Homer can honestly jump that high. So if Homer jumps, he's going to jump very low. If Bugs Bunny jumps, he's going to jump very high. And this is how we're able to have different variations. Dive deep into the code and show you guys how I made this happen. Okay. So here's the game controller. Up here is where I instantiated the high jump, medium jump, and low jump. Okay. And on update, we're checking if we hit E, we're going to go ahead and call a low jump dot activate, call the method, and then we're going to pass it Homer. Okay. If we hit R, we're going to be like, hey, medium jump, call the method activate, and then pass it SpongeBob, etc. with Bugs Bunny. And then, say for example, we want so many different characters. Usually how people would go about doing this would be really inefficient because they would have to make a whole function for each of the different players. But since in this case, we're able to literally call whatever function we want to use with the player on the game controller, which is really effective. Okay. So once we call this low jump activate, medium jump activate, high jump activate, we're going to go ahead and call the activate method with whatever tag we want to look for. In this case, Homer, SpongeBob, or Bunny. And in this case, I'm going to go ahead and go to the low jump and say we already hit E. So we hit E, we pass the low jump Homer. Okay. So this is the activate method that's inheriting from the parent class activate. So when we hit activate in the game controller, we're going to go ahead and take the name Homer or Bugs Bunny or SpongeBob and then call the main method jump from the parent class we're inheriting, and in the parent class where we define jump. So you can see that low jump has a vertical of 0.5. High jump has a vertical of 10, and the medium jump has a vertical of 1.5. This is how we're able to have different variations for each of the different jumping abilities. And we can continue making more jumping variations by saying super high jump or the highest jump. And we can keep on going and go ahead and keep on changing these variables to go even higher and higher so we can have different variations. Okay. So I'm going to go ahead and go into the main jumping class. And as you can see, it's an abstract class. And after we call the jump method inside the activate method in the children, it goes ahead and passes the vertical and the name to the parent class jump method. It'll take that vertical, it'll take that name, it'll look for the object with the tag, for this example, Homer. It'll attach Homer to the player, and then it'll be like, hey, make Homer jump this amount high. And Homer, like we said, and from the game controller, he's attached to the low jump. we can easily make Homer jump really high by saying, hey, Homer, jump. So now, if we play the game, he'll be able to jump really high. Okay? So I'm going to go ahead and show you guys that. So now, nobody has a low jump anymore. Homer and Bugs Bunny share the same jumping functionality. And as you can see, Homer can jump really high now. As you can see, Homer, just by changing a simple line in the code, was able to jump really high. And this is why applying the sandbox pattern is really efficient and effective. Being able to change just a couple lines of code simply from the client and the ability to change the whole outcome of what you want the character to do is something really special that the sandbox pattern lets us do. And you can go ahead and just switch all of these. If you want, you can even make SpongeBob jump really low. And we're going to go ahead and even give Bugs Bunny a low jump as well. We're going to see how this will work. As you can see, simply by just changing a couple lines of code, we changed the whole character's outcome.
Good afternoon, CIS 414. I am Ryan Wilking, and today I will be going over the factory pattern and the decorator pattern. I decided to implement both of these by creating a graphical user interface in Python using Kinter. I would have liked to use Unity and create a game and show you the implementation inside Unity, but unfortunately I'm still not very familiar with Unity and my PC does not handle the scenery very well, so it makes it very hard for me to tell what my code is actually doing. So I really wanted to just keep it simple and focus on how these patterns work and their importance. So a little overview of the factory pattern. The factory pattern is just a creational pattern that provides an interface or a parent class to create objects of a particular class. So in this instance, we have a widget factory. It delegates the object instantiation to the subclasses or the derived class. This pattern is implementing the widget factory base class with several derived classes such as the button factory, label factory, cat image factory, and doge image factory. Each derived class implements the create widget method that returns a specific widget object based on the factory's purpose. So in this case, we're looking at returning a Kinter object for all four of these subclasses. This one would be a button, this one would be a label, and then these two would be an image. A little overview of the decorator pattern. This is just a structural pattern that's going to allow new behaviors or functionalities to the existing object dynamically without changing its structure. This pattern is implemented using a widget decorator base class with two derived classes, the bold text decorator and the color decorator. Both decorators inherit from the widget decorator base class and implement the create widget method to modify the widget object created by the widget factory. So in this case, we have the widget decorator that is going to instantiate a new object of the widget factory. So basically, the widget decorator itself is not doing anything until the bold text decorator radio button is actually checked, or the color radio buttons are being checked. So just returning a unique widget based on these actual factories or these actual objects. This one would return a bold text button, so a button with bold text, or a label which is just text that is going to be bold. And then the color decorator, I believe we have, let's see here, we have, yeah, black, red, and blue. And that's just going to return a button with text that's either going to be black, red, or blue, or label, which is just text, and that's going to be black, red, or blue. So to visually see and put the factory pattern and the decorator pattern that I had implemented in this graphical user interface, we can kind of visually see what's going to be going on here. So you can look at this dropdown as basically the widget factory base abstract class, in which it's not going to do anything because nothing is instantiated. So if we click add, nothing's going to add. So what we'd have to do is click the drop down and actually select one of these factory objects. So here we have a button. We can add a button. We can add a label, cat, image of a cat, and an image of a doge. So that's basically the factory pattern, adding as many objects as we want based on the factory itself. We don't actually have to go in and change any code or modify any code. So now incorporating the decorator pattern with the factory pattern, the decorator pattern is only going to be consistent with the button and the label. I could not figure out a way to decorate these two images, or at least I did not try to. So we can click on a button and we have these decorators down below, which are just radio buttons. So we have the bold text decorator, and then we have the color decorators. One's going to be black, one's going to be red, and then one's going to be blue. So we can go ahead and change the color of this to decorate this object. We click add, and here we have a button that is decorated with red text. Now we want red text, and maybe we want bold text. So we're going to check bold text, and we're going to decorate it with bold text and red. And as you can see, the text is bold. We can also do this with the label text. Maybe we don't want bold text. Maybe we just want to decorate it blue. So we're going to select the label, and we're going to decorate it with blue. Okay, so maybe now we want black text instead, and we want it to be bold. So we're going to click on the bold text and the black text, bold text and the black color, and then we're just going to click add. So now we have text that is bold and black. We could also change it to red. We could also change it to blue. We could also undecorate it. We can go back and create a new object with pretty much no decoration at all. And yeah, that's pretty much it. We have the factory pattern, the factory objects, and then the decorators down below as radio buttons. So yeah, thanks for watching.
Thank you guys so much for watching. Feel free to ask any questions. Feel free to leave your comments in the comment section as well. Today, we went over the tower defense game, the PartyParty game, and the AstroBlaster game, where we implemented all 14 advanced object-oriented design patterns and showed you guys ways to implement them as well. Thank you guys so much for watching. Hope you guys have a fantastic day.